All right, guys, this is number 27 on the new portion. Okay, and remember, 27 and 28 are off limits as far as the exam, but I did want to walk through them because several of the things that we do with them, we've done in class. It's just kind of a combination that we hadn't really talked about in class. And again, 27 and 28 ended up on the review because I was running out of options for like word problems. So that's how they ended up there. All right, so hey, you got your box, it's 1,500 kilograms, you've got two angles, you've got two tension cables, and so here's what's happening. You have the box, and it's kind of like right here, right? And ultimately what you have is you have three vectors that are acting on it. You have this vector for the first cable, and then you have a second vector. Well, I'm going to name that F1 first of all. So F1 for force 1. Oh, I should probably pick a different color. It was very close to the other red. And then you have this other vector, or this other cable, I should say, and that's force 2. And then you have basically, let's go with the blue, you have force 3, which is, the weight and the gravity. So what you're going to do is you're actually going to write three vectors. This you can totally handle, this you can totally do. But what's interesting about this is that this box isn't moving, so it's in what's called static equilibrium, where basically the forces that are acting on it, when you sum them, they equal 0. Okay? And remember, when vectors equal 0, their I components, they add up to equal 0, I should say, the I components add up to equal 0, and the j components, add up to equal 0. Okay, so that's going to come in handy in a few minutes. Couple other things you might want to remember is that you've got alternate interior angles here. So that's 45 degrees there. Alternate interior with parallel lines, I should say. So throw back to geometry. And then you've got them here. So you got 60 and 60. All right. So we're going to write force 1, force 2, and force 3 as vectors in a linear combination, AI plus BJ. And ultimately, I'm actually going to write the first one first, because that makes sense. All right, so remember, writing a linear combination of a vector, you need the magnitude, which you don't have. That's actually what we're looking for. And you need the angle, which we do have. You're not allowed to use 45 degrees for that one, because remember, the angle has to be in relation to the positive x-axis. So I'm going to write m for magnitude there. That's just a variable that I'm picking because we don't actually know the magnitude of that force. And then, of course, it's m times the cosine of 135i plus m times the sine of, and of course I'm running out of space, 135j. All right, so force 1 in linear combination and leaving it as a radical is going to be a negative radical 2 over 2 mi plus a positive radical 2 over 2 mj. Then we do the same thing for force 2. So force 2 is going to equal, I don't have the magnitude there. I can't use m because I've already used it. So I'm going to use p for the power of the force. And of course, now I'm thinking about Star Wars. So p times the cosine of, you can actually just use the 60 degrees there, and that's I, plus p times the sine of 60 degrees j. And so force 2 equals p, 1/2. Cosine of 60 is 1/2. So 1/2 pi plus radical 3 over 2 pj. Oops, that's a terrible radical 3 over 2. Sorry about that. So those are your two forces. And then your third one is very simple to write, because your force, the magnitude of that, it's 1,500 kilograms. I mean, that's the weight. So really, force 3, you can write just very simply because it's heading straight down. Yes, you can do with the angles and do cosine of 3 pi over 2 and sine of 3 pi over 2, but really what ends up happening is this bad boy looks like 0i, minus a 1500 J. Okay, so you've got those. Now here's the thing. I'm going to switch to the next page, and I'm not going to rewrite these. So I want to call attention before I head over there. The I parts, I'm going to add them up and set them equal to 0. So basically, negative radical 2 over 2m and 1/2 p. Okay, so the I components are going to add up to be equal to 0. And then the j components, I'm going to also add up to equal to 0. Let me pick like another color to highlight that. So you got radical 2 over 2m, you've got a radical 3 over 2p, and then you have this negative 1500. Okay, so set your I parts, add them up equal to 0, and then do the same thing with your j's. So when we're doing this, we are going to have a negative radical 2, this is my I parts, negative radical 2 over 2m plus, okay, then you have, sorry, I think the recording like interrupted me, so 1/2 p equals a 0, so that's your I parts, right? And then you also have your j parts where you set those up, radical 2 over 2m plus radical 3 over 2p plus the negative 1500, so those are all your j parts, those have to equal 0. So basically what we're going to do is we're going to take that first equation and we're going to solve it, and then we can substitute. It's really just two equations right now. It's just two equations, two variables. It's just a system of equations. So I'm going to add radical 2 over 2m to both sides. So 1/2 p equals a positive radical 2 over 2m, right? And so then I'm going to multiply both sides by 2 to get rid of that fraction. So p equals radical 2m. And so I can take, let's pick a different color, this, and plug it in to there. Okay, it's not the nicest thing going on because we're dealing with our radicals, but it's okay. We can handle it. Oh, no, sorry. I'm like, wait, that doesn't make sense. There we go. You plug it in there, not in the first one. You leave the m's. Goofball. All right. So, radical 2 over 2m, that was left over, plus radical 3 over 2 times our radical 2m equals a 1500. I added my 1500 to both sides. Okay, so you have a radical 2 over 2m plus a radical 6 over 2m equals a 1500. I'm going to multiply everything by 2. When I multiply everything by 2, I get a radical 2m plus a radical 6m equals 3000. Okay? And then what I'm going to do is actually just factor out an m. So I've got m times radical 2 plus radical 6 equals 3000. And yes, you could have done all of this by just writing the decimals for radical 2 and radical 6, but you can also do it this way. All right, divide everything by, both sides I should say, by this right here. Please be careful. You can plug in your 3000 into the calculator, and then please, immediately after you hit the divide, put parentheses, radical 2 plus radical 6, close those parentheses. And so what you get for that force of the magnitude on that, I believe it was the first tension or the first cable, so that tension is 776.46 kilograms. Okay? And then for the second cable, you are literally just going to take your 776.46 and plug it in over here. P equals radical 2 times 776.46, and you get 1098.08 kilograms. That's tension on the two cables. And remember, basically like the first half of the video is everything that we've done in class. This last half where it's kind of like, oh, you've got static equilibrium, you're setting things equal to 0. That's a little bit more than what we did.